Hello, this is Vijay Subramanian. I'm here to talk about my final project for CS6963. The app is called StreamViewer. The goal of the app was really to develop a tool to collect forensic data from network captures offline. Some of the ideas behind the project are really covered in Network Miner, but Network Miner doesn't necessarily have all the features like session level views, GeoIP location, and then the free version. And add-ons such as capturing telnet sessions, FTP command logging, and VirusTotal integration don't exist in Network Miner natively, although some add-on modules are available. So StreamViewer is really intended to be a quick tool to organize the contents of a PCAP into FTP, HTTP, and telnet streams, look into them, and extract stream-specific packets or files transferred, and look at some ratings in terms of malicious URLs or blacklists. So here's a quick feature comparison or a list of features for StreamViewer. There are three different categories. The first category is visualization. This is really the GUI, the web GUI, which at the highest level starts off with a summary of the streams, then provides a stream level view of each stream, different URLs accessed and methods accessed, methods used for HTTP sessions, and for all sessions we'll have GeoIP data, ASN data, full session log, and for FTP and Telnet we'll do command logging. StreamViewer also allows us to download or extract downloaded files, including the file names, as well as just extracting a PCAP for the specific stream. Username and password extraction is also available for FTP and Telnet sessions. From a site reputation and blacklist checking, I use URL void here instead of VirusTotal due to the limitations with VirusTotal in terms of only being able to pull for 4 entries per minute. URL void gives us about 1,000 entries per day, and most of the backend databases are kind of the same anyway. Simon is again another aggregator for IP blacklist information. It polls many different sites and gets different blacklist categories for destination IP addresses. So here's kind of an overview of the reference model for StreamViewer. It's a browser-based app. So on the client side, there's the browser. In my case, I used Google Chrome. The server side is implemented entirely in Python, and I've used the Flask micro framework as the web application framework. So essentially, Flask provides a collection of utilities and tools to turn a normal app into a web app. It does that by a number of different things. It has Jinja templates where we can create base HTML contents and inject Pythonish code into them to generate dynamic HTML. It also can integrate well with Bootstrap, written by Twitter, where we get a rich set of tools and utilities for generating, front-end content. For the backend, for the database, I've used MongoDB with MongoAlchemy as the interface. For PCAP dissection, it's predominantly done by PyShark and Tshark. And there's a utilities module which does pretty much most of the packet processing, file extraction, HTML generation, and data correlation. There's also an extension of the utils modules for what I'm calling Web API. That's really used to interface with external data sites like RIPE, FreeGeoIP, URL Void, and Simon. This is all the supporting data information required to collect the data. And the Web API is really sending HTTP requests, converting the responses back to XML and JSON responses back to classes and dictionaries that the app can use. There's also a lightweight logging module that I had to implement for this. So the client side generally just sends HTTP GET POST requests or AJAX or jQuery requests to the Flask web app, and then the Flask web app really does all the processing behind it and returns the HTML to the client side. So quickly, I'll cover some of the limitations and known issues. I covered it a little bit earlier. URL void only has a limit of 1,000 queries per day. I took care to reuse existing queries so that if we had a list of 2,000 entries but only 500 of them were unique, we're only querying each of those one time to save valuable query resources. From blacklist checking, Simon sometimes reports issues that have already been cleared. We'll see that more in the demo. From a file extraction perspective, no tool really does a perfect file extraction for every PCAP we put out there. In our case, PyShark, Tshark have some limitations in terms of HTTP content length not being reported well, that results in not all files being extracted. Another limitation is the file name to 32 characters. It's to avoid long names that go beyond OS limitations. Again, this is an artifact of using Flask. There's a concurrency issue where only one kind of query to the back end from the client side can be worked on at any given time. So in my case, I have a status puller from the client side querying every 3 seconds. So if the back end is busy doing some other processing some other query, that results in a broken pipe error. This is largely cosmetic. It's a case for future improvement. So let's go to the demo. Let me launch my session here. Okay, so I'm using Linux Mint 18 as the development platform, and I have Chrome as the browser. So in order to get the application launched, you have to go into the application folder, and we see there's a Python script here to execute to start the app, and then all the app files are really in the StreamViewer app folder. So we launch the app by typing that command in it. Right away we see that Flask has started a web server running on a local host on port 5000. This terminal here also serves as our server logging session, but we'll kind of close that now or minimize that. Okay, so now we're going to go browse to the URL, and we see the main splash page kind of load up. For StreamViewer, there's a couple of different things here I'll go through. This obviously is the nav bar. You can click on any of these things. There's the main area here where we select the PCAP file to be uploaded. There's a status bar here to convey backend server messages, server-side messages to the client side. And this is where the packet summary is. You can click on HTTP, FTP, and Telnet to parse, to look at the specific protocol, packets from the specific protocol. Down here is the contents area where all the messages will be displayed. So let's go load up a PCAP. I have a sample PCAP here based on public PCAPs available, and I've crafted some PCAPs myself and combined them. So you select it and you click upload, and a bunch of things are happening in the back end here, where the PCAP file is first uploaded from the client side to the server side, and once it's down into the server side, then the PCAP file is kind of accessed. The relevant streams are extracted from the PCAP, and the database is then populated with all the relevant entries. So once this is done, we should see a summary here of all the FTP, HTTP, and Telnet flows that are available to us in the PCAP for further viewing. Okay, so that usually takes a few minutes for that to happen. Once it's done, we get a message saying the PCAP file is loaded, and we can see now that the summary view has been populated. We know we have 76 HTTP sessions. We can kind of scroll down here and look at all the HTTP sessions. We know we have 3 FTP, and 3 telnet sessions. So let's jump in and take a look at one of the HTTP sessions. So all we have to do is go click view here. While that's pulling up, we'll notice the stream ID from the PCAP is 114, source, destination, IPs, and the site. So here we go. We've got details about that particular stream here. Stream ID is 114, obviously. Site is thewayoftheninja.org. We see ASN information and the owner of the ASN. We know it's in the UK. Since it's a European site, typically European sites only show the country, whereas most sites in the US will actually tell you country, city, state, country. We can also see from a URL void perspective, there are no reported issues for this site or IP. From a IP block list perspective, we can see Simon reported that that Google Safe Browsing reported this as a potential phishing site, and then URL Query also said this potential malicious activity here. If we wanted to follow and see what URL Query actually said, we can click here. This option, the click option, is not available for every site. We'll come back to that in a little bit. Down on the right, we can see there's 2 buttons, extract files and extract packets. This is to extract any downloaded files, and this is to extract this particular stream from the overall PCAP. Down below, we can see a full URI list. In this case, there's an HTML file that was loaded, a CSS file, and a bunch of images. And you all using the get method. Obviously, we'll also see posts here if there was any post method used. We can also, if we don't like this view and we need the raw stream data, we can look at it using this tab. And this is essentially like the same thing as doing follow TCP stream in Wireshark. So we can actually see a wealth of information here in terms of response headers, response codes, and actual packet bytes here in ASCII format in any case. So this is particularly useful if you really want to get to the raw data behind it and not waste any time looking elsewhere. So let's go in and see if we can extract some files here. So when we click that, we get a zip file here that comes up. Essentially, I chose to zip the files instead of send them one by one, just for easier file transfer and just kind of keeping all the files in one spot so we can save them. So we can go click open on that zip file, and there we go. So now we have kind of most of the files that were accessed. We can click on any image file. We can see it says playonline.gif. That's the file. We can also, for example, take a look at the HTML file. Let's say we'll open it up in gedit here. We can see the HTML. So that's pretty useful. Let's take a look at another flow really quickly here. Let's say we pick reddit.com just to give you guys another view into this. Again, it says it's getting the stream. That means it's processing. Now we know stream 9 is loaded. Here we go. This is destination's US based, so we can see city state information. In this particular case, URL void reported some issues. So the one database that did report issues was Scumware. That is the database that's reporting the issue. Whereas in the IP block list Simon, these are categories: phishing, malicious activity, DNSBL, and these are the particular sites within there that is reporting some issue or the other. Okay, so I mean, let's click on one of these things and see what comes up. Once you click on that, it opens up a new page here. a new tab, and we can see here, although it's reporting some issues, there's some stale data from a Simon perspective that Simon's reporting really. It's generally pretty accurate. In some cases, we always see some old data. Okay, again, we can also look at the raw TCP stream log here. What I didn't really cover was extract packets, so let's see if we can extract the packets here. And again, it gives you a file here that's downloaded, and go look at the PCAP. And that should load straight into Wireshark. Okay, so here's that stream in Wireshark, captured all the way from the first SYN packet to the very end. And then basically, if you don't like the raw stream log view, you can actually go in here if you want to look at something specific in the headers or elsewhere. So that's also pretty important for us to be able to do that. Okay, so let's move on to FTP in the interest of time. So when we click on FTP, notice this still stays the same. You know, we can go back and forth, so we don't have to necessarily keep reloading this. But once we click on a FTP session here, we should see the FTP session load up. Again, wait for the status bar to change to know, there we go. So we can see in this FTP session, the first session is pretty straightforward. It's just somebody logging in under username administrator, password Napier, just a bunch of commands, and they've exited. After that, this is a private RFC 1918 IP, so you know we can look that up from an ASN and a IP block list perspective. The session log is really a full log of the session, both client and server traffic, right? So the client side is denoted with an FTP greater than sign, so we can distinguish between the two. The command log here is really all the commands that the user, the client side, put in. So let's look at session number 2 here for FTP, and see in this session there should be some files transferred. Let's see if that comes up. Still getting the stream. Okay, so now we see FTP stream 3 has been loaded. Again, it's private IP. Now we can look at the command log, and we see now there's 2 files that have been transferred, one using the store command and one using the retrieve command. We can go click extract files, and we get a zip file again. Now we can go in and open this file. Okay, so here we go. We see same 2 files, 111 PNG and manual.txt. We can double click 111 PNG, and now we see the file kind of loaded up on our picture viewer here. So that's the gist for FTP. You know, we've got the full session log, command log, username, password, and files, and extract packets is the same thing as HTTP, where it just pulls up the PCAP specific to this particular stream. Now let's look at Telnet. Telnet, again, let's click on the second stream there. Telnet's pretty much the same as FTP, except there's an extra tab in here. And I'll go through that again. It's a RFC 1918 address, so there's no ASN or IP block list. We'll click on one of those other ones next. The command log, again, these are the commands that the user typed in. We have username and password extraction, and basically kind of the commands that the user typed in. This is only from the user's perspective. If you look at the session log, this is bi-directional, meaning if you did a script command in external, this is kind of the output you would expect to see, both the client and server traffic. The raw session log is also client session server traffic, but in this case, the client and server, the server echoes of the client input is also echoed. So in other words, for Telnet, when we press the L key, let's say, the L is transmitted to the server side, but the server side also echoes it back to be displayed on the screen. So that's what this is capturing. The raw session log takes all that stuff out. I mean, the other session logs take all that stuff out. The raw session log includes everything. So that's kind of the difference between the raw session log and the normal session log here. Let's take a look at the third one in the flow here. Or maybe even the first one. Okay, so here's another example. It's a public IP that I changed the PCAP to. You can see the ASN, location Germany, again, same thing, username, password, session log, and raw session log. They're all in here. Okay, so that concludes the demo.